Welcome to part 8 of this Classic D Class D amplifier build. Greetings, I'm the Astro 30 and welcome to another installment in this series. Today's little topic is going to be doing the internal wiring of all the PCBs here, including the pre-amplification circuits at the front. Now, what I plan to do is I'm going to wire the high side first to the bridge rectifier, from the bridge rectifier to the power supply module, and they require crimp connectors, splayed terminals, basically these things here. I've got another packet of them somewhere. I've only got 2 red ones. Well, that should be enough. But first I've got to verify the pin out of this bridge rectifier. So in a previous video I surmised that because we know where the positive is and where 1 AC is, if we follow the way that the diodes will be wired together internally, as opposed to over here with this standard bridge rectifier notation, then we should see an anode here and a cathode here at this pin, which would denote where our AC connection is, the other one, and over here we should have 2 anodes, which forms the negative. So all we have to do is use a multimeter and diode test and find out. So that's what we're looking at down there. Okay, so I'm going to first start with positive to this pin over here, which should be the other AC connection, and that should be 1 diode, which it is. As you can see, we've got 524 millivolts across it, so that's indicating a diode. So if we go from that point here now, which is the AC connection, should be a cathode. Directly opposite that should be its anode, which it is, again 520 millivolt roughly. So where my red probe is now should be the negative, and there should also be another anode from there back to this main AC pin here, which there is, 535 millivolt. We already knew 1 AC connection was here, the other one's over here, positive's over here where it's marked, and the pin's in a different direction to the rest, and there's the negative. So it does conform to the standard bridge rectifier layout with these style of packages, including the PCB mount ones. Now it's just a matter of wiring it. Now I've got to get the primary, the blue and the brown, into the same connection point as this first transformer. Now I'm also going to use this IEC socket, which computer power plug, whatever you want to call it, which has an inbuilt fuse in it. I've already stuck a 5 amp slow blow in there, which is what this transformer requires. But because I've got 2 transformers, I don't know if it's going to blow the fuse. So I'll wire that up and connect it to the terminal block down here as well. And yeah, we'll see whether it works or not. So first I'm going to connect up the transformer and this connector, and then do a test. Alright, so there's the IEC socket all wired. I'm going to need to insulate the whole entire socket from accidental contact with the mains, and this pin here is the live pin, and yeah. So I'm going to use this IEC condom boot. Now it's a simple matter. I haven't got the earth tag on it yet, but it's a simple matter of just passing the wires through the boot. There we go, and orient it in the correct direction, and just put the condom on the socket. And yeah, there, it's fully insulated. There's just one problem with this. There's now not much space between the back and this transformer, so I can't mount this central with the back panel anywhere, because it would be just tight, so I'd actually have to raise it up almost close to the top of the back panel just to clear that transformer. So I'd have to measure that properly, but yeah, I reckon it would come down a good 10 mil from the top. I mean, that's fine. However, I could mount it sideways, but it's still pretty tight. I mean, the other solution is I could actually just trim the boot down a bit, like take so much off, because it doesn't need to really be this long. But that's something I'll look at a little bit later. Let's cut the bloody thing off. Oh, man, I've got some gas this morning. Okay, so I've got the lead plugged into the socket. The socket is just temporarily wired across the terminal block on both the active and neutral points. There is supposed to be a switch in between, but it's not in there yet. I've got the voltmeter set to the AC scale across one winding of the secondary, the black and the red wires. These other two floating up the top here are the other secondary. So as soon as I apply power, I should see 35 volt, roughly, AC on the meter. So here we go. And we've got 36.7 thereabouts, and the fuse did not blow, so that's great. I need to verify the other windings working as well, so I'll just swap these leads around. I could have done it live if I was careful, but it's not really advocating correct safety procedures. So we'll have a look at the meter. I'll plug it back in. We should also see around about the same, 36.7. 36.7, yeah. So alternating current wise, the transformer's fine. It's not going to blow the inline fuse in the socket. So 5 amp is fine. Now I've got another problem. I thought I was prepared, but I only have one of these blue ones. Now I've got plenty of red ones, but I need to denote from, well, the difference between the positive and the negative, so blue and red. So I'm going to have to go out, back to Kingston, which I'm not happy about, go to JCar and buy another packet of them. So I've just wasted most of the day doing nothing and achieving nothing. So I've basically achieved nothing in the last hour apart from farting 3 times and wiring up some AC wires, which was not really that difficult in the first place. Okay, so I'm going to go out to the electronics store and I'm going to purchase another packet of these. And I'm back with some more splay terminal connectors. So to denote the ends of each winding, which is the red and the orange wires, I'm going to use 2 blue connectors. And these 2 centers, the black and the white, which have to be joined together to form the 0, I'm going to use a red connector, and I believe that both these wires will fit into this connector. Well, I can at least, get the jam in there somehow. Okay, I'm going to have to change that around because these blue ones actually have a wider diameter thing that accepts wire in it. So I might be able to get both in here just nicely, which I think, yeah, that's going to work. So I'm going to use it that way around. So be red to denote the 2 secondaries and blue for the center. This is all the way in. I believe they are. We'll soon find out when I pull on it and it comes back out. Start at the back here. Okay, that should be crimped. No. The insulation is moving backwards and forwards, yes, but the wires are not coming out. So that can route under, or on top, no, under the mains wiring and go straight to its connector point, which is there. Yay, watch the Astro 30 crimp connectors. Right, that's a red one. So I think that might have gone a little bit too far, but as long as it stays in there, which it does. I've got 3 of these red ones on the desk now. I keep pulling out new ones and not using the one that I've pulled out. Okay, so crimp this one. When all else fails with the crimping tool, carefully use a pair of pliers. But don't cut all the way through it. Right, that should be crimped. So we need one AC connected to there, and the other one is connected to there. So I need to just maneuver these wires around a bit, and I should cable tie them as well. And that just dropped under the chassis somewhere. That's fine. Alright, so now I'm going to hook up some test leads to the positive and negative connections of the bridge rectifier there, and we're going to measure the DC voltage in it. Alright, so when I plug this in now, we should see close to 70 volt DC on the meter. So plug it in. Close to 70, we've got 67.6. And the reason why it's only at that voltage is because it's unfiltered. So now, next step is to wire up the rectifier, positive and negative, to the power supply module. And then we'll do a final voltage check here at the output to see what the voltage is. Now we've got 35 volt AC coming in from the transformer secondary. We multiply that by 1.414. That's DC rectification plus smoothing would have close to almost 50 volt. So if we multiply that by 2, we're going to have close to 100 volt coming out that connector across both the positive and negative connections, and close to 50 between the positive to 0 and the negative to 0 respectively. Now the way I like to do these crimp connectors is with the wire that I'm putting in it. I like to tin the wire first. A lot of people may disagree with doing that, and you certainly don't do it when doing it in a car, for instance, but yeah, I just think tinning the wire gives it a better connection. And the one thing I hate doing in any project is the wiring. Just saying. There. Grip it there. And one, if I can, there we go, there for good luck. And it's always a good idea to give it a little bit of a tug, as rude as that sounded, just to make sure that it is actually crimped and it's not going to come flying straight back out the connector, which has happened, which means you've got to start again, and you've just wasted a connector. One, so across that way somehow. Okay, again I can't get it, so I'll just use a pair of pliers. Right, that one should be crimped, and now I've got to do the same thing with the black wire. There we go. And this side I can just route around the transformer here, and negative goes to there, positive goes to there. It doesn't feel very tight, but it should be right. I'll probably end up zip tying these two wires to the transformer's secondary on the 15 volt. In fact, I might actually just do that now. Instead of just talking about it, let's do it, eh? So I'll go around, not the AC side, but, well, the main side. I'll go through the secondary side. Okay. Just to keep those wires neat. Okay, now I just need to cut that end off. Okay. Right, now I can hook up the multimeter to the DC output and see what we get when we plug it in. Hopefully nothing goes bang. If it does, it'll be spectacular. Okay, so with the multimeter hooked up to the output, this is going to be a good test of the fuse in line with this IEC connector to see if the inrush current of this transformer plus this one isn't going to blow the fuse. So let's plug it in and find out. Contact. And wouldn't you know it, no issue, and we have a healthy 100 volt DC coming out of the power supply. It's actually dropping off by 100 millivolt every so often. It's settled down now. Oh no, there it goes. 0.7, 0.6, 0.5, 0.6, 0.5. Okay, that's enough of that. It's stabilized now at 100.5 volt DC. That'll drop once it's connected to the two power amp modules, which is going to be what the next step is to hook up the amplifier modules to the power supply. Now, be aware that this is now potentially lethal. We have 100 volt DC just lying around the center of the chassis here. We have to give it the respect it deserves, because let's face it, there is a big difference between getting shocked by an AC voltage at 100 volt than there is getting shocked at a DC voltage at 100 volt. That's potentially lethal. Now it's dropped up to 99.9. Now it's come back up. Now I've just noticed that's because, that's interesting, someone just started up either an angle grinder or a saw next door, and the actual AC input voltage went down. So did the DC output voltage. So that also is a good indication that the house wiring is crap. Anyhow, I'm going to turn that off now and we'll watch it slowly decay off. Actually, it is bleeding off quite fast, believe it or not. Oh, look at it go. But yeah, as I said, there is a lethal potential sitting in the middle of that chassis, so once it's powered up, do not come into contact with the power supply or the power amplifier modules. That's why there's two LEDs on the circuit board there, so you know that there's power there. So anyway, moving on to the next step, which is hooking up the power amp modules. And the story so far is I've got both modules hooked up to the power supply. All these 0 wires go to the star earth, so the high power side is being earthed. So yeah, that power earth. It comes from one point of the power supply over here, because, well, you don't need to connect the other side to earth as well, because it's physically joined anyway. So that's all hooked up. So now all I've got to do is power it up and see if anything goes bang, or that the run lights on those modules come on. So we'll just look at one run light here and see if it comes on. Don't really like leaning over it whilst I'm powering it up, but both LEDs lit. So the other one. So both amplifiers are alive. It's alive. Ooh, isn't that special? Alright. Now there is an extra red wire just hanging around out in the breeze here. That goes to the speaker protector module, which is going to be the next thing to wire up. But that only needs low gauge wire. It doesn't need this heavy gauge 7.5 amp wire that I've got here. So we'll just unplug that and yep, they went out. So now I'll hook up the speaker protector relay, at least to the power supply, and then worry about hooking up the protect leads into it. So I'm doing this step by step. I know this is a long drawn out process, but you may also notice the tone amp and the volume control board are missing. That was just to facilitate wiring in the high side here. So let me get about doing the speaker protector and we'll come back. Alright, so now the power supply is hooked up to the speaker protector module, so I'm just going to verify that that is functioning. So I plug it in. This should engage up to 2 seconds. There it goes. That's perfect. Now that's going to take a long time to drop out. I don't know how long. No, there it goes. Ah, there I go. Right, next step, to probably go to the toilet again. However, next step would be to hook up these leads for the Protect module to connect to the power amplifier board, so at least this relay is being controlled by these modules, and also hook up the Protect LED at the front here, which is now awfully difficult to get to because there's a heatsink in the way, but I should just be able to get into there. So I'm going to get about doing that task next, and after I've done that we'll move on to, I think what I'm going to do is I'm going to bias, that is align both these modules so they're sitting at 500 kilohertz each, because this one here is only just roughly set up, so they're not balanced at the moment. But first I'll do the wiring for the Protect section, including the LED, and then we'll come back. Okay, my penis. Well, there's always one that wants to be a prick. Right. Solder all that great. Okay, so that's the Protect section wired up to the power amplifiers and to the LED at the front. So now when I plug it in, what should happen is this LED should light momentarily and then go out once the relay engages. So I'll just knock everything off the top of this, move that over that way, and we'll plug it in and have a look. And there we go. So we saw the light came on there momentarily and then went out. So now, to test the operation of the protection circuit, I'm just basically going to short LK3, which is the to GND. That's the Protect for each module. So to test the operation here. It goes into Protect, comes out of Protect, goes into Protect, Comes out of protect. Brilliant. Now when I unplug it, 2 seconds later, the relay drops out, but the protect LED comes on and it'll slowly fade out with the power supply. But yeah, that's okay, I guess. A little bit annoying that that's how it's being done, but yeah. And we can see the power supply caps are holding a charge for a pretty long time. And that's only coming off of one side of the capacitor bank. There it goes. Off the one side of the supply between that and 0. So, but very, very good. That is, don't want to pull on that too much. Find some way of hooking that to, tying that to something later. But next step would be to play with my penis. No, I did that this morning. Is just cable tie these wires here together, and I think I might start by wiring the low side wiring for the positive minus 15 volt rails to every other board, and then tighten these boards up in there just so that they're all connected. However, I need to get to an audio connector down here, so I'll keep that in mind too. Anyhow, I'll figure it out as I go. So anyway, moving on. Oh, Jesus Christ. Okay, 4 hours later, I've got some progress, but I'm still nowhere near ready to have output coming out of it. Got the input audio signal wires done for the most part. The 15 volt rail wires to each 3 modules here done. All zip tied in. I'm running out of zip ties. I'm going to have to buy some more tomorrow. So what's left is the actual input to the preamp to go run right back to the back of the board, and also to wire this double cable here to each of these RCA sockets for the inputs to the power amp. And well, the outputs aren't wired to anything yet, and they're not wired to the relay. So before I can even output anything, these are going to have to be aligned. So I will do that after I've finished doing these last 2 cables. Well, actually 3, including this one for the subwoofer. So, but what I'll do for this is I won't put a connector on the end of it yet. I'll just strip the wires ready for one and just use what do you call them, jumper wires from the end of the cable to the speaker that needs to make it work. Just so I don't have to have the input circuit board in there, because I still haven't wired up the power for that. But what I want to do is get this into a working state to a point where we can get some form of output. Fucking Windows updates. When you want to use the bloody thing, it wants to update. Okay, so whilst I'm waiting for the computer to boot up, I'll just say that I've wired everything now, bar the output to the speaker relay. I'm going to bypass that for now. It's not really necessary in the interim. I haven't got the connectors wired at the other end for the input and output cables respectively, but that's fine. I've got 2 ×10 probes connected to the DDS sitting next to it, DSO sitting next to it, both on the VS pin and ground respectively. I think I did mention ×10, because that puts out quite a fair amount of voltage if you're not careful. And I'm going to do the alignment of the 2 channels here and see if there's anything weird on the screen. Okay, I've got everything ready to go now, I think, so I can plug the amplifier in and hopefully nothing goes up with a bang. Here it goes. Am I nervous? A little. Alright, nothing went up with a bang. However, I can't see anything on the scope properly. So as we can see, the 2 frequencies are way off from each other. So I have to adjust the second module I built to match the first. The first one being the yellow trace is the one that I built previously. The one with the green trace is the newer one. So I want to say and call it there that that's as close as I'm going to get it. Both waveforms look reasonably like they're aligning with each other. So next it'd be a good idea to see if it's actually functioning as an amplifier all the way through the preamplifier circuitry to the power amp. Currently I've got a dummy load on the right hand channel now and an input at 1 kilohertz 1 volt going into the preamp on the right hand channel. I've got channel 2 of the scope measuring the subwoofer output, and I've got channel 1 measuring the power amplifier output. Oh yes, it's working as an amplifier, I can see it is. Yeah, now it's clipping. As I rotate the control, I can see both traces are moving. So remember, the green one is the sub, so the sub's getting some out. So we're clipping there. Alright, so before clipping we've got a voltage peak to peak at 81.5. So 81.5 we'll say, divide that by 2 equals 40.75, multiply that by itself equals that divided by the load. It's 207.5 watts. That's with only one channel driven, so it would probably drop to about 180, but yeah, it's pretty capable. Okay, so I'm going to swap over to the left hand channel now, and just, verify there's an output. So I've got to turn it off first. Okay, I'm hooked up to the other channel now, so we'll just verify that it's functioning. Well, for some reason there's not much coming out of the left channel. Yeah, it helps to switch the input over as well, so I'll just hook it back up to the power amplifier and we'll try again. So now we're hooked up to the power amplifier. Yeah, that's functioning. And we've got probably about closer to 90 volt coming out of that channel, so all very well and good. Right, so now I guess it's time to hook it up to some speakers, the subwoofer, and yeah, see what happens. Okay, I got both speakers hooked up plus the sub. Yes, it's a mess. I've got the CD player hooked to the audio input, but it's not turned on yet. What I'm checking for is any unusual noises coming out of the speakers. So I'm going to plug it in, and it's not going through the relay, so nothing unusual. Bit of a buzz when I turn the volume up. I can hear the trebles working. Anyway, now we need an audio source, I think. Okay, so let's try this. See that bass distorting? Okay, that's enough of that track, that's getting annoying. Okay, yes it is working, but there seems to be some issue with the bass control distorting it. Not sure what's going on there. But generally speaking, I can't hear any noise coming out the speakers. Heat sinks feel fine. So I might just try another track and see if bass is an issue. Seems fine. It could be just an issue with the particular track. The sound should disappear when I plug it into the headphone socket, which it does. Brilliant. Cheers. See you in the next video, guys.